Good morning, children. Welcome to my class. I am introducing the first chapter, that is the number system, the backbone of mathematics. You know what is a number system? It contains different types of numbers. I will explain just natural numbers, then whole numbers, then integers that you have learnt in 6th class. Then last year you have learned rational numbers, that is in the form of decimals and fraction. So you imagine mathematics is a cupboard. So many racks are there. Each rack is a number system. How? And see, this is mathematics is a cupboard, and the first number system, natural numbers. So I am opening the rack. Natural numbers means all counting numbers are coming. So some counting numbers I have written. This is the first cupboard, natural numbers. Then the second one, whole numbers. Only one number is added in this group, 0. Then all natural numbers. So example, whole numbers. The next third branch is integers. Integers included natural numbers, whole numbers, then negative numbers. So this rack is little big. All negative numbers, positive numbers, 0. That means integers included the other two racks numbers also. Next, move to rational numbers. Rational number is a big box. It contains natural numbers, whole numbers, integers. That means 0 is there, negative numbers, positive numbers. Other than this, some additional numbers are there. That is our fractions and decimals, and see the rack. So all this 4 number system you have already learned. And this year you are studying another type of number system, that is irrational numbers. All this together we can mark on a number line. That is the real number system of mathematics, the backbone of mathematics. Then I will ask some questions to you. We can leave irrational numbers up to rational numbers. All natural numbers are rational numbers. Yes. So always think about the river is flowing. Flowing, what is it? In front, moving towards. Similarly, all whole numbers are rational numbers. Yes. Next I am asking, negative 3. Is it a rational number? Yes. Negative 3 is an integer. Integer is a rational number. And backward direction is not possible. For example, I am taking here negative 3. Negative 3 is a rational number. Negative 3 is an integer. 1 is a natural number. 1 is a rational number. 0 is a whole number. 0 is a rational number. But backward direction is not possible. All rational numbers are natural numbers? No. All rational numbers are whole numbers? No. All rational numbers are integers? No. But integers are rational numbers? Yes. Whole numbers are integers? Yes. Natural numbers are whole numbers? Yes. That means moving towards. And this is the backbone, the number system of mathematics. Now I am explaining the definition of rational number. What is a rational number? A rational number is a number which can be written in the form of P by Q, where P and Q are integers, Q not equal to 0. Such numbers are called rational numbers. For example, natural number 3, which can be written in the form of P by Q. That is 3, you can write 3 by 1. Which can. And 0. 0, is it a rational number? Yes. 0, we can write 0 by 8. Any number we can write, the answer is 0. So such numbers are called rational number, which can be written in the form of P by Q. And our present motion, irrational numbers. What is irrational numbers? Opposite of rational numbers, which cannot be written in the form of P by Q. Such numbers are there? Yes. And I'm starting with our perfect squares. I'm taking the perfect square one example. Root 9. Root 9. What is the answer? Either positive 3 or negative 3. Because positive 3 into positive 3, 9. Negative 3 into negative 3, 9. So root 9 is an integer. It is a rational number. And such a perfect squares are rational numbers we can write in the form of p by q. Now I am taking another number, root 2. Can you write in the form of p by q? No, it has no perfect root. So such numbers are included in the section of irrational number. Root 2, root 3, root 5, root 10, root 11, root 7. And such numbers are included in the irrational numbers. And these numbers, one another name is also there, surds. S U R D S. Surds. Surds, in simple way I will tell the definition. Surds means we cannot remove root. For example, root 3. We cannot remove root 3 because we are not getting a perfect number, perfect square root. So such numbers are called surds. So all surds are included in irrational number. Then another number. So your favorite number, romantic number, pi. What is the value of pi? Pi, for our convenience, we are writing 22 by 7. 22 by 7. What is the answer of 22 by 7? 3.141592, etc. And these decimals never stop. It is a non-stopping decimal. We don't know. We can write more decimal places this number, pi. Also, the digits are not repeating. The same digit is not repeating. And such category, such numbers we can include in the set of irrational numbers. So irrational numbers are both non-stopping, non-repeating. Such numbers are called rational numbers. So pi is an example of an irrational numbers. Why? So irrational numbers, correct definition, either surds or non-repeating, non-terminating. That is a word used in your textbook, non-terminate. Non-terminate means non-stop. Then non-recurring. Recurring means repeating. So these are the two conditions. Never stop, never recur. Both non-recurring, non-terminating, decimal, and such numbers are called irrational numbers. So pi, that number, it is non-stopping, it is goes on, and the same number is not repeating. And such category, such number is included in irrational number. This is another branch of, this is not included in other four set of system, and this is a special system, that is the special rank irrational numbers. And some irrational numbers I have written open the rank, root 5, root 6, and pi. Then some other numbers I will show you. It doesn't repeat, non-terminating and non-recurring decimals. And this is a number system of mathematics. And see this board, real numbers. So the last section is real number. All these 5 systems together. That is, real numbers are the union of rational and irrational number. Rational means our all 3 systems included, integers, natural number, whole numbers. So real numbers are the union of rational and irrational numbers. So our real number system is only rational and irrational together. Their union is called the real number system. Then another, every irrational number is a real number. Yes, I told you, rational and irrational together is real number. So every irrational number means root 2 or 22 by 7, 3.1414, etc. Because each decimal or this type of number, there is a place in the number line. So these numbers we can represent on a number line. Such numbers are called real numbers. Then every real number is an irrational number. Is it correct or wrong? It's wrong. Every integer, this I will post for you. You have to write the answer true or false. Every integer is a whole number. This is your work. Then every rational number is a whole number. You have to write true or false. Then pi is an irrational number. And these are about irrational number, which is non-terminating and non-recurring decimals. And this is the definition of rational number. A number which can be written in the form of p by q, where p and q are integers, q not equal to 0, that q is n union w union I. Union of all three, you are getting rational numbers. What is irrational numbers? Irrational numbers which cannot be written in the form of p by q. Okay, that is root 2, root 3, pi, root 15 I told you. Then irrational number is, this is the definition, non-terminating, non-recurring decimals. Non-terminating, and the decimal goes on, never ending. And non-recurring, the same decimal is not repeating. And see the decimal, 0.1011, then 0, then 11, 0, then 11. We cannot predict what will be coming in the next decimal places. And such numbers, such decimals are called irrational numbers. But all these numbers we can represent on a number line. All these numbers we can represent on a number line, so we can call it as real numbers. This is our real number system. Then you know, any two rational numbers or any two rational numbers, we will get many rational numbers. For example, if you take 2 and 3, two rational numbers, in between you will get infinite rational numbers that you have learned last year. So you are expanding this number 2 by 1, 3 by 1, and you are expanding and you are finding so many rational numbers. So one exercise question is there, I will post it. You have to do that. And similarly, or in easy way, you can write 2 and 3 are two rational numbers, 2 plus 3 by 2. So 5 by 2. 2.5 is the middlemost number between 2 and 3. So for every two rational numbers, there are infinitely many rational numbers. So this is our number system. Then specially I am taking irrational number. Irrational numbers means the number non-stopping, that is non-recurring, non-terminating. Okay, can we represent these numbers on a number line? And decimal places, okay, we can take it, how to mark it. So this is the first is representation of such numbers on a number line. And the first one is a surd. Root 2, root 3, such numbers, we don't know the correct value of such numbers. That numbers we can represent on a number line. So representation of irrational numbers on a number line, if they are surds or non-terminating, non-recurring decimals. Okay, and the first one is how to represent root 2 on a number line. So root 2, representation of root 2 on a number line. We don't know the correct value of root 2, but we are representing root 2. Anyway, it is greater than root 1. Root 1 is 1 and root 4 is 2. So in between, so 1 and 2. So that number lies between 1 and 2. So root 2 means it is between root 1 and root 4. Root 1 is 1. Root 4 is 2. So anyway, root 2 is in between. That is, the value is in between on a number line. So what is the method of representing such irrational numbers on a number line? So you draw a number line. Draw a number line and the middlemost number, that is 0. Then before that I am asking who invented these irrational numbers, and it was whether it is correct or not, we don't know. It is only the sayings of Pythagoras, and after finding the rational numbers, he invented some numbers are repeating such non-recurring decimals. He got the answer first, but he didn't kept a secret in his mind. He didn't tell his devotees about this matter, and later only he invented this irrational number system. But he got this answer when he was finding some numbers. He got such number system, but he didn't tell this to the world about this number system. So this is known as a Pythagorean secret. These irrational numbers are Pythagorean secret. Now we know the the truth of the secret. So irrational numbers. And now other two mathematicians, that is Dedekand and another mathematician, they have also studied more about irrational numbers. They became mad after finding such type of numbers. So how to represent root 2? So why I told root 2 and Pythagoras, why I connected, because root 2 we are representing on a number line using Pythagoras theorem. And what is the Pythagoras theorem? Pythagoras theorem, base square plus altitude square is equal to hypotenuse square. Okay, we are constructing a right triangle on a number line, and like that only we can represent root 2 on a number line. So how we are getting root 2 using Pythagoras theorem? Suppose the base is 1 unit and altitude is also 1 unit. So base 1 unit, altitude 1 unit. So 1 square 1, altitude square 1 square 1, 1 plus 1 2. So hypotenuse square is 2. Hypotenuse is root 2. Base square 1 square, altitude square 1 square, this equal to 1 plus 1 2. So hypotenuse equal to square root 2. And that is why I connected this number to Pythagoras also, because using Pythagoras theorem we can represent it. So how to represent? So 0 is the middlemost number. Take 1 unit from 0. 1 unit means you can take 3 centimeter, 4 centimeter. If it is 1 centimeter means it is very less. So 2 centimeter or 3 centimeter, like that. That is your 1 unit. 1 unit, there is no restriction. What centimeter you are taking, that is a 1 unit. Suppose I am taking 2 centimeter. 2 centimeter. I am marking this as V.